You guys ready? First notes back. So law of cosines, guys, I don't know if this is, well, this is a geometry topic, but I don't know if they taught it to you in geometry. Were we in a pandemic when you guys were in geometry? Okay, so towards the end, right? Okay, so for a triangle to exist, guys, the two smallest sides must be larger than the largest side. So this C there is the largest side. So the sum of the two smaller sides must be larger than the longest side. If you do not meet this requirement, you do not have a triangle. Pretty simple, right? And then let's see, what type of triangles can we have? We can have an acute triangle. So 3, 4, and this is not 5. I'm just going to call that C. That's the letter C, little c. We can have a right triangle. 3, 4, and I know this is a 5, but I'm going to call it C. And we can have an obtuse triangle. 3, 4, and I guess let's put 60 degrees here, 90, and 120. And I'll call that C. Nothing crazy, right? Pretty simple, straightforward so far. When is it an acute? Whenever c squared is less than a squared plus b squared. When is it a right triangle? Whenever c squared equals a squared plus b squared. And when is it obtuse? Whenever c squared is greater than a squared plus b squared. Hey, Jarella. How do we feel? Nothing crazy, right? Okay. Let's talk about how to label triangles real quick. You label triangles with 3 vertices, and you usually call the vertices with capital letters. I'm going to put an A right here. I'm going to put a B right here, and I'm going to put a C right there. Angle A creates little a, so that's side length from point C, or from vertex C to vertex B, that's side length A. That makes sense, guys? Angle B, the opposite of angle B, this is little b, so that's side length little b. And then angle C creates little c. How do we feel so far? All right, so we're going to derive the law of cosines instead of just give you the formula, because I think you guys want to see that, or at least I hope. So I'm going to draw a grid, and I'm putting that same triangle. It's that same triangle, but I'm putting the vertex A at the origin. And I'm just going to copy paste. That's a capital C. Capital B. It's supposed to be the same triangle, but it looks okay, I guess. Are we still all right? So there's angle A here, so that created little a, so this is still little a. This distance still here is still little c, so that means point B is c comma 0. Does that make sense to you guys? And then I'm going to call point C vertex C. I'm going to call this some x comma y, some coordinate. And of course, this is still little b. ¿Cómo te sientes? That means how do you feel? But if you take it in a different context, it means how do you sit? ¿Cómo te sientes? So talk to Ms. Marks about how proper Spanish. ¿Cómo te sientes? Like, how do you sit? ¿Cómo te sientas? Oh, I got schooled. Okay, thanks, Miss. Yeah, you know what? That's why I don't teach Spanish, see? So, Ms. Marks, if you're listening to this, I just got schooled. I'm recording this one, so. What was that? You killed it? All right, guys, let's focus. Do you see that green triangle that I tried to outline? You know what? I tried to make a dashed line, but I'll just make it solid. You see that green triangle? I'm going to use that. That green triangle is a right triangle. So let's see, what am I going to do? I'm going to do cosine and sine of that specific angle. So cosine of A, remember that cosine is opposite. Remember that cosine is adjacent over hypotenuse. Do you guys remember that? So this adjacent, this distance here that I'm making bold, isn't that just some x value? Like this specific x value? So cosine A is x over, and what's my hypotenuse? What letter do they have? B. Does that make sense to you guys? Yeah. And because I probably am going to use the x in a little bit, I'm going to write x equals b cosine A. All I did was multiply both sides by b. Do we have any questions on where that one came from, guys? Please ask, because I can't read minds. Okay, here's the second opportunity. I'm going to write sine A. Remember that sine is opposite over hypotenuse. Do you agree that this that I'm making really bold, that this is just a y value? See? That's just that specific y value, no? So sine is y over, again, b. So if I multiply both sides by b, I get y is equal to b sine A. Are we still okay? All right. What if I told you that I want the distance of segment A? So if I told you that I want the distance of segment A, I would hope that you would tell me, well, I can figure that out by distance formula, right? So distance formula, A squared, remember distance formula and Pythagorean theorem, my brother and sister, equals the difference in x's. So I need this right here that I'm bolding. So what is the difference? It's going to be c minus an x squared plus. Does everyone see where I got that from? Okay, all I'm doing is trying to get this in blue here, guys. So that in blue, the distance from the vertex A all the way to vertex B, that is c. And I'm subtracting that in green, and that in green is that x value. That makes sense? Okay. Plus, let's see. And then I need to get the difference in y values, so it's going to be y minus 0 squared. Are we still okay? All I did was use distance formula, guys. Distance formula. Which is similar to Pythagorean theorem. I'm just going to put PYTH. A squared equals B squared plus C squared. Or A squared plus B squared equals C squared. Doesn't matter. How do we feel, guys? Okay, now check it out. I'm going to replace the x. Chavez, what are you going to replace it with? With B cosine A. So I'm going to write A squared equals parentheses C minus B cosine A, close it squared, plus, and I'm going to replace the y with B sine A. B sine A, close it squared. Are we still okay, guys? Now all I'm going to do is algebra, law of exponents. So here we go. A squared equals, and all I'm doing is foiling. What is C times C? C squared. Then I'm going to go C times B cosine A. That's going to be BC cosine A, but I'm going to have how many of those? 2. So I'm going to write minus 2 BC cosine A. And then negative B cosine A times negative B cosine A is going to be B squared cosine squared A. Is everyone okay with that? Plus, and then this guy, I'm just going to square that guy. B squared sine squared A. How do you sit? ¿Cómo te sientes? I'll stop, guys. I'll stop. Right? ¿Cómo te? Okay, I was corrected earlier. All right, so check it out, guys. This that I'm underlining, I can factor out a b squared. So now I have a squared equals c squared minus 2bc cosine a plus, here's my b squared factored out. And then notice what I have on the inside here in parentheses. What is cosine squared plus sine squared? Just 1. This is just 1, guys. Nomás uno. I don't know French. How do you say 1 in Japanese? Ichi? Ichi.
Oh my gosh.
That's cool, right?
I know it too.
Oh, okay. A squared equals. So here's where we're going to rewrite it, guys. We're going to rewrite it. We're going to put the b squared in the front. Then you're going to put the c squared in the front. And then you're going to put minus 2bc cosine A. And guess what you just derived? This is called Law of Cosines. That's it. You just derived it, guys.
Like we're lawmakers.
Yeah. Take a guess. What if I put b squared on the outside? Then how would it look? Use context clues. A squared plus c squared minus 2ac cosine b. All right, you guys tell me. What if I put c squared on the outside? A squared plus b squared minus ab, okay. Cosine.
C.
Perfect. All three of those are law of cosines. It doesn't matter. There it is. You just need two sides and an angle, and you can figure out another angle or the other way around. And that's it, guys. That's it. Now we're just going to use this formula over and over again. What do you guys think? Was that cool or what? I think it was cool. So how do we use it? None of my triangles are to scale, so I'm going to put not to scale. Does everyone have a calculator? Make sure your mode is in what mode? Degree. So here we go. They tell me triangle PMF. So I'm going to try to make it look like, I'm going to see, that looks like a right triangle. I want it to be obtuse. There we go. So this is angle M, 127 degrees. PMF. So this is little p. Little p is 15.78 feet. This is little m. We do not know little m. And this is little f. Little f is 8.54 feet. Does everyone know, like if they give you these, can you guys draw this triangle? Okay, let me know if you have issues with that. They want you to find the measure of side M. All I'm going to do, guys, is use one of these formulas. They're all the same, really. So if I want to figure out side M, so here it is. M squared, I'm just doing law of cosines. M squared equals f squared plus p squared minus 2fp cosine of M. Do I have everything? Do I have side F? Yes. Do I have side P? Yes. Do I have angle M? I got everything I need, guys. So here we go. I'm going to take my calculator. I'm going to go 8.54 squared plus 15.78 squared minus 2 times 8.54 times 15.78 cosine of 127 degrees. And that's going to be M squared. So I take my calculator. Here's my calculator. It's in radian mode, so I changed my mode to degree mode. Degree. And I already forgot my numbers. Can you guys help me out? What was it? 8.54 squared plus 78 squared minus 2 times 8.54 times 15.78, and then cosine of what? 127. Push enter. Now be careful. That is not the length of m. That's m squared, right? So let me go here and I'm going to write m squared equals 484.1426. 484.1. I already forgot it. Short-term memory, guys. 1426. 1426. How do I figure out m from there? Yeah, just square root that sucker. Can I say that word? I think I can, right? M equals. I'm going to square root it. So here we go. I'm just going to put second square root, and then I'm just going to scroll up, push enter. So there's my number, push enter again. And there it is. It's a nice 22. Did it tell me to round? Find the measure of the third side. Nope. So I'm going to use 3 digits after the decimal. 22.003. Well, how many digits do they use? 2? Okay, I'm just going to use them 2. 22.00, so leave it alone. And I need units. With a happy face. Look what we just did. Cool, right? What do you guys think? Yeah. Question 2. Don't worry, guys. We're going to be done pretty quickly. It says in triangle XYZ, x equals 3, y equals 7, z equals 9. Find the measure of the largest angle. So I'm going to put not to scale. And I'm going to write, there is a way to figure out whether it's acute, obtuse, or right triangle. But for now, we just care about x, y, z, about finding this measure of the largest angle, right? So this is little x, which is 3. This is little y, which is 7. And this is little z, which is 9. Actually, you guys do know how to figure out whether it's acute, obtuse, or from right here. From this. But no big deal. Let's just figure it out here. Not to scale. Which one's the biggest angle? Angle X, angle Y, or angle Z? And why? Angle Z. So obviously it's 100% not to scale. Angle Z is the biggest one because length Z is the largest. Does that make sense, guys? So when I use my law of cosines, I'm going to put the Z on the outside because it's cosine of angle Z. So I'm going to go 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of angle Z. Does that make sense, guys? Okay, you're done with pre-cal or geometry, and now all you're doing is just algebra. 9 squared is 81, 3 squared is 9, 7 squared, what's that, 49? Minus 2 times 3, that's 6. What's 6 times 7? What is it? 42, yeah. Cosine Z. You guys okay so far? All right, what's 49 plus 9? Yeah, 58. 42 cosine Z. And now we're just doing algebra, guys. Subtract the 58. Subtract the 58. What's 81 minus 58? 58, 68, 78, 23, 22, 23. 23, right? 23 equals negative 42 cosine Z. We're trying to get cosine Z by itself, so I'm going to divide by negative 42. Divide by negative 42. So I have cosine Z is equal to negative 23 over 42. And then to get angle Z by itself, you just do the what? Inverse cosine. Negative 23 over 42. So let's see what we get. So I take my calculator. Inverse cosine. Negative 23 over 42. Let me know if I made a mistake. I make mistakes all the time. 123.204. 123.204 degrees. And there it is, guys. So this was an obtuse. It's obviously not to scale. And we could have told it was an obtuse if it followed this right there. So let's see. Let's see if this is true. C squared is greater than A squared plus B squared, the largest side. So let's see. 9 squared. Is 9 squared greater than 3 squared plus 7 squared? Yeah, 9 squared is 81. 3 squared plus 7 squared is 58. Yep, obtuse. Cool, right? I think it's cool. Happy face. And yeah, we're pretty much done. We just do more just for practice. Suppose that length of the sides in example 2 at 3, 7, and 11. What would the measure of angle Z be in this case? Let's do it for fun. You're going to see something's going to happen, guys. Not to scale. And I want you guys to see something. It's supposed to be the same triangle, right? 3, 7, and 11. And they want you to figure out angle Z again. So do the same thing. 11 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine Z. I'm surprised no one has stopped me from looking at that triangle. 3 squared is 9. 7 squared is 49. Oh, wait. Oh, yeah, everything's correct so far. 2 times 3 is 6. 6 times 7, is that 42? Cosine Z. So I still have 121 equals 58 minus 42 cosine Z. Subtract 58, subtract 58. What's that? 58, 68, 78, 88, 98, 108, 118, 63 equals negative 42 cosine Z. Divide by negative 42, divide by negative 42. Cosine Z equals negative 63 over 42. If you try to do the inverse of this, guys, you're going to get an error. 63 over 42. Look. Arc cosine of negative 63 over 42. Can you tell me why I get an error? It's not a triangle. Why is it not a triangle? Remember the rule was, in order for you to have a triangle, the two shortest sides must be larger than the largest side, like when you sum them up. Is 7 plus 3 larger than 11? No, that's 10. So you don't even have a triangle. What you really have is something like, let's see, you have something like, it doesn't reach. You have something like that. If this was a swivel, it would just go back and forth. That's what you have, guys. This ratio on the inside, did I say that right? That ratio, that better be a number between negative 1 and 1. That ratio has to be a number between negative 1 and 1, guys, for this triangle to exist, for this angle / triangle to exist. Does that make sense to you guys? Okay, if that doesn't make sense, just make sure that it follows this rule. If the two smallest sides, when you sum them up, is not larger than the largest side, you don't have a triangle. Cool or not cool? Okay. All right, and so now let's just do some problems that Delta Math has. I put 2 of them in here. So let's just do these 2, and then we'll set you guys loose. Cool? So it says, in triangle TUV, letter V is 20, little t is 11, angle U is 47. Find length of U. So not to scale. Here's my triangle. I like to label them T, U, V. So they gave me little v. So little v is 20, so I'm going to put the 20 right here. They gave me little t, so here's angle t, so this is little t, 11 centimeters. Make sure we're able to put those in there. And this is 47 degrees. Obviously, it does not look like 47, so that's why I put not to scale. They want length of u, so I'm just going to do my law of cosines right off the bat. U squared equals 11 squared plus 20 squared minus 2 times 11 times 20 cosine 47 degrees. Heck, I'll even do one better for you guys. Just take the square root of all that. So let's see. Square root. And I already forgot the numbers. What were they, guys? 11 squared plus 20 squared minus 2 times 11 times 20 cosine of what? Well, 47? 47. Enter. There it is. That's my number. 14.863. I already took the square root, guys. 14.863. What did they want? Find to the nearest centimeter. So nearest centimeter, 15 centimeters. How do you feel? Do we feel like we got a lock on this for the most part? Okay. What other questions are they going to ask you? They're going to ask you to find angles. So let's do this one. This is the last one, and then we'll set you guys free to delta. So example 5, JKL. So not to scale. JKL. Little j is 9.6. Little k is 6.4. Little l is 8.4. And it says find the measure of angle k. Okay. Because they want angle k, this is the one that you're going to have on the outside of your equation, quote unquote. Does that make sense, guys? So I'm going to write 6.4 squared equals 8.4. There's what I mean by outside. You know, it's by itself. So 6.4 squared equals 8.4 squared plus 9.6 squared minus 2 times 8.4 times 9.6 cosine of k. They want you to find angle k. You already did. That's it. That's your pre-calc or geometry. The rest is just algebra. So you're going to need your calculator now. So someone tell me what 6.4 squared is, guys. What is it? 40.96. Perfect. Okay, I couldn't hear you. What's 8.4 squared? 70.56. What's 9.6 squared? 92.16 minus, and then someone multiply these three numbers. 2 times 8.4 times 9.6. What do you get? Perfect. You're done. Now you're just doing arithmetic. Add these two numbers up. Point what? 7.2. The most common mistake is that you guys like to subtract that 161.28. There is a product, guys. Don't do that. Subtract 162.72 from the 40.96. What do you guys get? Negative 1, 2 equals negative 161.28. So now what do? Divide by what? Perfect. Negative divided by negative is a? Perfect. So now I'm going to have cosine k equals some number. To get k by itself, you do the inverse of it. And you'll get your answer. What is that? What'd you guys get? 40.978 degrees. What did they want? To nearest what? To the nearest degree. 41 degrees. And that's it? That's all you're doing? You guys think you guys can handle this? It's not that bad, right? What's up? All right, guys. Good job. Good day back. It's on Delta. I think you can finish it before you guys leave. And that's it.